In this example, we're going to be taking the definite integral of the fairly complicated function e to the sine of x squared, evaluated from 0 to 5. Trying to find the analytic solution to this is not going to be very easy since we have a compound function. We are raising e to the sine of something, and that something is x squared. So trying to use substitution or something else for this might not yield us a good result. We might not be able to find the antiderivative. However, since it's a definite integral, we're evaluating it from defined bounds of 0 to 5, we should be able to do this one numerically to come up with that answer, even if we can't get the antiderivative. I'll start by just clearing everything out from Matlab, giving it a fresh start. And I'm going to define the function that I want to integrate. So I'm going to say y is I'm just going to use an inline function here since it is a pretty straightforward one, at least to write. So e to the sine of x squared. Right, so we have our function defined here, and let me just plot this. I'll define xt here from 0 to 5, so we can take a look at what the function looks like. So I can plot xt, y of xt, and we see we get an error here, but that's because I'm trying to use a vector in here, and it's not defined for use in the vector because I didn't include that dot. So now it does work properly. So this is our function plotted from 0 to 5. So what we're trying to find is the area under this curve for this entire length here. Let me give it a little bit more detail. Right, so again, the area under this curve, since this is my x-axis here, the area under the curve will be the integral when we evaluate it from 0 to 5. Because we're just finding a single integral here, I'm going to use the integral function in Matlab. So first I have to tell it what is the variable I'm integrating with respect to. That will just be x in this case. And then my function is y of x. And I want to evaluate at a lower bound of 0 and upper bound of 5. So if I run just this line, I get that the definite integral is 6.7975. Again, the area under this part of the curve between 0 and 5. So very quickly we get a solution, a numeric solution to this. And I'm going to show just another way we can use this. Is I can put in more than one argument here as long as I know what variable I want to integrate with respect to. So if I want this even more general and I want to have a coefficient here, let's say some variable c that I want to define, then when c is 1, I can see what this plot is going to look like. Right? And that's exactly what we just looked at. C was 1. But let's say I wanted to integrate sine of 2 times x squared. Then I could put a 2 in here. And we see we get a different plot. So what this allows us to do is now with the integral command, I can actually put in a second value here. I can put 2. So again, as long as I'm matching this x to this x, I'm saying that whatever the first argument was in my original function up here, that's what I'm integrating with respect to. And then I can find these different integrals here when, in this case, x, that c value I added was 2 versus 1 versus, let's just say 3. And we say we get slightly different values depending on that value that I put in there. So for example, if I wanted to be integrating a bunch of different but similar functions, maybe that just differed by that value of c, I could do that in a loop, and I can just use this integral to use the definite integration of my function between the two bounds.